So this week what we're going to be doing is what I playfully call optimization problems. We've learned how to work with a function. We can graph them, we can solve equations with them, we can do all kinds of good things with some function. And the idea in an optimization problem is we're going to either be given the function. So the function is either we're going to be given f of x, or we're going to be given information where we can build f of x. And then once we do that, once we either have it or we build it, what we try to do is basically try to find maximums and minimum values. So that's basically the idea. What's nice about 4.4, since we've learned about quadratic models, all right, so a typical quadratic is ax squared plus bx plus c in general form, but we also have it in standard form. What's nice about quadratics is they're either parabolas that are opening down or they are parabolas that are opening up. So there's a pretty obvious maximum point or minimum point, right? We call those a vertex when regarding to quadratic models. So optimizing things that have a quadratic equation behind them is pretty easy. We just basically look for the vertex and the minimum. So that's basically that. However, right, there's more models. We're eventually going to go back to 3.6. I know I skipped that section a while ago, but I just didn't think we were ready for it just yet. So we're going to handle optimization problems in something that's easy to do, if you would, and then we're going to go back and do 3.6 problems where we continue to max and min, but we're not going to have quadratics. We're going to have radicals involved. We're going to have x cubed involved. We're going to have square roots of squares in it. It's going to be crazy. But once we get the idea of what's happening in 4.4, we can go back and take a look at the idea in 3.6. Okay, so that's basically the goal then, is we're going to try to find, we're either going to be given a function that we find a max or a min to, or we're going to have to build a function that we find a max or a min to in order to do this. And concentrating on the building, if it's given, we just use the function. But given a function, this is what's going to happen. We usually have something that needs to be optimized, but we also have some sort of constraint. And putting these two together, we're going to build the function that we're after. Optimizing, maybe we want to optimize an area, or I want to optimize my profit for a company, or maybe I want to optimize my revenue, all right, or maybe I want to minimize my cost. Okay, whatever the case might be. And so, or maybe I want to minimize volume or maximize the volume of a shape. So there's something to be optimized, but then we have some sort of constraint. In a business model, profit, revenue, and costs, there's budget concerns, there's my workers, right, because maybe they can only work so fast. There's the market itself. Okay, that's usually what drives an optimization problem, because the market itself drives what I can or cannot do in terms of optimizing my profit, my revenue, or minimizing my cost. As far as area and volume is concerned, perhaps we're limited by some sort of a shape. We're constrained within a circle, or constrained within some sort of a graph. So that minimizes or maximizes what I can do with that area. So there's going to be two equations eventually when these get harder. An equation that needs to be optimized, and then some equation, and sometimes there's more than one constraint, that when we put these two and two together, we can build one overall function that I can eventually find maximum ends to and get there. So obviously there's a lot to do, a lot of work, there's a lot of word problems in this the next two sections. So we're going to handle 4.4 and 3.6 this week. I think on the calendar I put 5.1, but after reviewing what's coming here, let's just focus on optimization problems, and then we'll do some polynomial work next week, and we'll catch up somewhere in there. But this is going to be pretty hard enough. So there's an overview. Again, what we're trying to do is, given a function, or if we create a function, when we're optimizing it, I'm trying to find where its maximums are or where its minimums are, depending on the situation. And so we'll begin that journey with some pretty obvious quadratics and just finding vertices again. And then we'll get a little harder going back to 3.6. So work ahead. Look forward to seeing you and talking to you guys in the videos.